Hello and welcome to Captain Bob. Today we're going to be trying something a little bit different. We're going to be in real time configuring this turn coordinator we made in the last video. This won't be as edited, so it'll be a little bit longer, but hopefully it can kind of show my thought process and how I go about getting up from mistakes and errors in MobiFlight. I hope you like the background. We have our lovely toiletries and everything because I'm in a college dorm now. The first step with every MobiFlight project is to open MobiFlight. We're going to go under our MobiFlight right here, and under MobiFlight modules, this is where we're going to start everything. So under first Arduino, yours will be named something different. I made a ball and an airplane. Let's go over to the wiring to see how this all goes. So right here we have our turn coordinator. We again made this in the last video, and we have our Arduino. I already wired things to this stepper motor, but my wiring was actually wrong, so don't pay attention to these numbers. I have a picture right here actually. The correct wiring should look more like this. I had this from the back. This is shown from the front, so it should go. You can see I have all of these colors, and it goes 1, 2, 3, 4. You can start with yellow and plug it in. Whatever pins I want to. I'm going to go with 2 through, I think it would end up being 2 through 5, just because those are the first available pins. You can use whatever you want. And then do the same thing. Start top right, 1, 2, 3, 4. For this one too, 1, 2, 3, 4. And of course this depends on your orientation. Refer to the diagram and you'll be golden. Then this one is going to go on 8, 9, 10, 11. Right there. So you have these coiled. You'll also realize I have 2 wires right here. This would go to your power supply to power the built-in LEDs that I designed for this. Okay, I already have these flashed, 8. And I have something done very special with them. The middle 2 pins on X27 stepper motors has to switch. And in the stepper motor video I made last time, like 4 months ago or something crazy, I actually switched it physically to show you could switch the middle 2 wires physically, or you could switch them in the software, what I'm doing. But you have to make sure you switch them, otherwise it won't work so well for you. So I made a new device, stepper motor, and then I just selected 2 all the way to through 4 for this one, or 2 through 5, 2, 4, 3, 5. And if you need to switch the pins, you have to unreserve that number. So like this, say up here, like use one that's not being used currently. And then you have to go back and select the desired pin, like this. So that was just me switching them. I'll switch them back because we need them switched back. So here's your wiring. You can go use whatever pins you want to. Just make sure they're in order and the middle 2 are switched, so not in order. And do the same for the airplane. This is for the ball. For the airplane, I used 8, 10, 9, 11. Yeah, 8 through 11, just switch the middle 2. And for auto 0 input, I used none because right now we don't have a zeroing mechanism. So you'll have to zero it through the software and just hope it doesn't get out of sync. Update this right here. Woohoo! Click OK. And let's go over to inputs. So this is going to be not inputs, actually outputs this time. Outputs, this is going to be airplane for the first row, and then for the second row, we're going to make ball. Alright, make sure to activate both of these, click edit, and then under SimConnect right here, we're going to search for turn, and hopefully we'll find it. It's not super apparent. Actually it is. Turn coordinator rate, I believe is the airplane, which is perfect. It's in radians per second, which isn't ideal, but we can work with it. Because this is in radians and we love degrees here in America, we're going to multiply it by 57.2958, which is what Google tells me is a radian point, like so many zeros. So we have this turn indicator rate selected right here. We have transform right here, we can select, and this allows us to change the equation. So we're going to multiply it using the little asterisk and paste that fancy number. Now our turn coordinator reads in degrees. Don't trust me, take a mechanical engineering course. We do so many unit conversions. So now we're all set for Microsoft Flight Sim 2020, but we're not really set for X-Plane. If you wanted to do X-Plane, you'd select X-Plane data ref, look up the data ref for your turn coordinator, and go from there. You can use something like the data ref tool to find that. Now we are at sim variable. I'm assuming this is correct. We might multiply it later to get it to be bigger. Let's go over to compare. This is what we'll use later. If we need to flip it, if we need values to stop, to pause, if we need to adjust values, we'll use this interpolation table. Under display, we have an output device. This is our stepper motor with our module right here. We have our device right here. We're going to use our stepper motor right here, and it's going to be the airplane we configured earlier. So this right here says whenever the sim goes a certain amount of value, the stepper will go a certain amount of value. It might be a total coincidence, but 27 squared for like the X27 stepper motor. Pretty sure this is a terrible coincidence, but it's a good way to remember it. 27 squared is 729, which is nearly exactly the amount of steps in this stepper motor. So if you're going to use the BYJ 2048 steppers, this value might work very well for you, but we're instead going to use this value because it's a different stepper, a whole new ball game. And we can either set this to 360 for 360 degrees, or I think we're going to set it to 3600. And I will show you why in a second. We'll just set it to 360 for now. Test value could be, let's say, 90 for 90 degrees. And let's press test. There we go. I had the wrong stepper selected. So make sure you actually have the right stepper selected. Airplane I had right here. We were testing value of 360 and 90. If I click test right here, it goes to 90 degrees right here. And when I press stop, it should return, but it gets stuck on my decal, which wasn't cut out very well. Editor Bob here. This is a new type of video style, so let me know if you absolutely love it or absolutely hate it in the comments below. But be nice about it. I'm sensitive, which causes me to have to take apart the instrument. Oh, anyways. So once I took apart the instrument, it's all like here, and if I go to test again, this time it's actually hitting its limit right there. Or is it? No, it's not. It's concerning. But this is all because okay. Okay, it might not be a bad idea to take the bezel off anyways, so you can adjust it manually and then set your 0. You can do it with your hands or with these numbers right here. So you can go +10 to move it, set the 0, and then once we press test, it works out. Of course, it did get jammed. This is purely a design error. I'm going to extend the rod so it doesn't interfere with the backing. Why do people like to take showers right when I need to film? Gotta have a conversation about that. No taking showers. Now, if we press test, we'll see it goes 90 degrees, -90 in this case. I changed it all the way to 90, and that's working great for us. If we want to go into Flight Simulator, we'll see how this basically coordinates. So to save this, name it something quirky, and then go into Flight Simulator. And out of the gate, we'll see the airplane lines up. Oh, we haven't pressed run. Okay. Now it still lines up. If we are to increase throttle, remove the parking brake, we'll notice that it doesn't really line up. I'll be completely honest. Right here, the 360 degrees here doesn't map up to the 360 degrees of the turn and slip, or the turn coordinator. Basically, I think like 20 degrees is right here, and I think the maximum is 70. How do you find the maximum? That's an excellent question. You'd basically do Top Gun flying and try to find it there. So you'll try to find just when the airplane hits the boundary and doesn't go further, and then you pause the simulator really quickly and try to find the value as close as you can right there. So what I did was I'd like turn real fast and then pause it right as the instrument, instead of like moving out smoothly, hit its stop. So we'll notice here's my Top Gun flying. It zeroes out at about 6. That's when it stops moving. And let's do our real quick pause. Yeah. Or like right here. -6. I think that's right here. If we multiply this by 100, we can get a more fine number system. So you'll notice right here, it's pretty jittery because it only has 6 things it's changing between. But if we want to make it less steppy, we can have there, instead of the 6 things it can be set to, we can set it to 100 things, basically increase the resolution. So that is what I hinted at earlier. Multiply everything by 100, and then under display, what used to be 360 now will be 360 with an extra 2 zeros, I believe. Now if we try I'm scratch this. We're actually going to keep this at 360 just so we can test with actual values, like -90 degrees. If we click test right here, that's, well, it should be. Oh, also, this needs to be stopped before you run the simulator, or before you run a test, so that's what screwed with that. But if we click test, this should be the -90 position. When we click stop, it returns to 0 right there. Bada boom, bada bang. What I might do is design stops into the instrument, something like that. See how that works. My prediction is that it won't, but I might try anyways. So we're going to keep the sim to stepper 360. I'm going to actually deviate from my notes and keep it 360 instead of multiplying it out. And then once it goes to input value right here, whenever it inputs a value, of negative 800, and okay, that just clicked. Negative 800 will output a value of, it should output a value of 60. 60 is the amount of degrees from here to there. So you can visualize 30, 60, 90. It's just the amount of degrees that the stepper motor is actually going. If we go back to the display tab, negative 60, put that in for the test value. I'm not doing positive numbers because they always get stuck. If we go to negative 60, press move, type in negative 60, press test. It goes right where we want it. That matches up with the game, the simulator. It's controversial to call it a game. So that's where we got this negative 60, and then the positive stop will be positive 60, and the positive value will be 800. I'm sorry I confused you right here with this 800. This is actually a better value. I saw this 60 and assumed that was, from my notes, and assumed that was the stopping point, but if you go over here, run, whoop, it does, woo. Yeah, it does look like it evens out closer to 80. Let's restart this flight. It says 60 right here because of our interpolation table. Again, we maxed out the stepper at 60, so let's turn that off and see what value we actually get. Oh dear. Let's get back on the ground. And this is just kind of spewing random crap right now, so that's why it's all crazy. I'll try to fly better this time. I'm actually a terrible pilot now that I quit training. I don't take it seriously enough. Yeah, you can either disconnect this stepper motor if it's giving you terrible feelings. Okay, so now we're in the air, and if we turn all the way left fast enough, and then pause it where it ends, it's stopping, like the instrument is actually stopping right, let's back it up a little bit, right there. Let's go back to it. Okay, now you're just making me look bad. Okay. It stopped for me somewhere around 700. And of course, this value you might have to change. So for me, I used negative 800. You might find you might work better with negative 700. It's kind of whatever leads to the best simulator for you. So let's turn this back on. We kind of need it now, and see what happens. It's going crazy. That's because we haven't defined a zero. I think that's most of it. The zero is way off because we broke it. Also, when it's running, you can't set the zero, so make sure to stop it whenever you're editing things. It's best practice, but really when you're setting the zero, you can't have it running because the running value and the calibration values fight with each other, like old friends. Or new friends. I don't know how your friendships are. Alright, set 0 where you want it. Press test to check. And now what we did was we set the negative 60 value to right there, positive 60 value to right there, because that's how math works. And then we set it to negative 800. That's a value we found over here. And negative 800 is what the sim said. and positive 800 is what the sim said here. So we should be all set. Click OK, click save, click run, and let's see how this goes. Already it's lined up. It's lined up here, and that's good enough for me. Right now we're not scientific, so we should be good. For ball, we're going to do the exact same thing. This time it'll probably be less cluttered because I'm good at what I do now. I've done it before. So search for turn chord and 3 results. Turn coordinator ball right here. Transform, and we're going to do the same exact thing. We're just going to add 1000 or multiply by 1000 this time. That'll increase our values because I think the values were really small. If we unhook this and just fly around, it's giving us like a percentage, which we really don't want. We want something that'll give us some oomph, you know? So now it took this from a percentage, which will just round to 0 for everything, and multiplied it by 1000, which gives us a pretty good range to work with. Like we have 1000 steps instead of 1 on or off. So now if we fly around, we can see it goes, and we can do our test piloted flying right here. 921 roughly is the limit there. You can even go more. Let's see if we can't fly even worse. We'll see what it maxes out at. I think it's maxing out around 1000. I did some even worse test flying than this, and you'll see we're not in a great situation right now as we are. But I did some even worse test flying before this and found that the values negative 1000 to positive 1000 are where the turn coordinator is shown because it's a percentage. Yeah, that kind of makes sense. Okay, you can even exit this little window here, go to hub hop, and look up turn coordinator under presets. And you can look up turn coordinator, this one right here, and it just tells you it's in the position. So yeah, you're kind of on your own for that one, but this oftentimes gives you good input, and usually it's actually this description here is the same one. It's pulling it from this and putting it into Mobi Flight. So you can always look at on hub hop if you want to have a little more fun, and then yeah. But yeah, everything from hub hop is actually shown here. The description right there matches the description over here, so there's not really an advantage to hub hop unless you're like you want to just look through them. But that's another tool. Thought I'd mention it. It's been a long day. So we have our percentage of turn coordinator. We multiplied it by 1000 to give us more resolution. Under display, we're going to do the same thing we just did. Select our Arduino, unselect it, select our stepper, select our ball, and for this, we're going to do same thing, 360, or actually no, we're going to do, we could go 1000, because we're having a value between 0 and 1000, it might as well make sense to have a value between 0 and 1000. So every time the simulator goes 1000, the stepper motor goes 720.29. You can either use 1000 and have your numbers all based on 1000, or for this I might actually go, even though my notes say 1000, I might go with 360 because that I think would just make more sense intuitively. The test value can be keep it low to start. The airplane doesn't matter what test value you use. Honestly, I really don't care. But it'll just spin until it reaches its limits. But this other one, it'll hit a wall, and then it might ruin your day. So just keep it low for these. the stepper motor isn't powerful enough to likely break itself, but you just want to be careful. So, what the actual... Oh, okay, I see what's happening. Make sure to stop your things before you edit them, says the hypocrite. And I was being super cautious, but these are really easy to work with, so yeah. We can zero it right here, and we're just gonna have it go all the way. Let's see. Okay. So we can click test right here, stop, test, stop, and that's 10 degrees. I think this is about like 70. I usually do a low test value just to prove it's working, and then I'll go increase it. I think 70 degrees is roughly this, or we'll start out with 45 degrees, see how big that is. Maybe it's 50 degrees. I could look in the CAD program I designed this in, but it takes a little bit of time to load. So we'll just kind of kill it. Okay, so it looks like 55 degrees is exactly how much this is, and that makes logical sense because I'm the type of person that designs things that end in 5. So that's great. 55 degrees is the entire amount of degrees from forward to backwards. Could even try 60. It might be 60 actually. No, it's 55. I just wanted to check. So that's the entire value, but we want to find the center value and then zero it off of there, just because that we want it to be like positive values are right, negative values are left, instead of having to subtract a magical number. So let's use a test value of 55 divided by 2, which is 27.5. Definitely did that on my brain. 27.5. I forgot it hates decimals. We'll just round up. Degrees here don't generally make or break your instrument, so we should be good there. And if you are ever like really in a pickle, you can yeah, you can just tap from there. So we found 28. I forgot you can't actually just like do this and then actually you can. Look at that. So that worked out perfectly. If you, dang it, I did not. If you test it, it works until you click stop. So I thought you could just, I mean, theoretically you can test it, get it to the right position, exit this out, save this, and exit this out, but it returns to the center position. I think they fixed that bug, which is which is good for me. Okay, I think they fixed that bug. It used to be that you could just exit out of it and it would like stay at the last place it was, but I think they fixed that, which is good, but also this really weird use case doesn't work. So you have to use these right here, move -10, move, or I guess it's positive in this case, move, and just center it right there. If you overshoot it, you can reinstate it or whatever. Make sure to press test 0, and now again, if we click test, you can see -28 to switch the direction, and it looks like negative is positive and positive is negative. I assume that's because of the way the design is made. Well, let's see, ball, yeah, in 1. Okay, we're good. I assume that's because of the way I designed it, but if not, that's also okay. So we multiplied it by 1,000, and our display, whenever the simulator goes 360 degrees, the stepper motor goes 360 degrees, 279 steps. I think it might actually be easier to work with 1,000, This number right here is kind of arbitrary. You could set it to 25 if you want. So whenever the simulator goes 25 steps or whatever, simulator variable counts, the stepper motor goes 229. I like to set it to 360 or like 100 for 100%, or in this case 1,000 for 1,000%. I'm gonna try it with 360, and then if I don't like that, I'll go back. So now we have this test value right here, -28, and we've determined that that's half of 55-ish. And if we press test, it goes to the edge. If we make that positive, it goes to the other edge. And now we can go to compare and basically put in these numbers. So if we recall, because this turn coordinator right here, hide the yolks, because this is just a percent, basically a value between 0 and 1, we know that the minimum value, or it's a percent positive and a percent negative, we know that the negative value will be -1 times 1,000, so -1,000. You know, we multiplied it. The positive most value will be 1,000, and the output value is what we have right here, -28 and +28. We might have to switch this. We'll see how it goes. -28, +28. We don't need this comparison setting right here. I don't know why that's checked. But we're looking pretty good. If we click OK, save it, run it, it's actually flipped. That I kind of assumed would happen because of the way when we pressed test and it went and we said +20, like right here, it goes left. So, and when we said -28, it goes right. So I kind of assumed that would happen. We can do two things. I'm pretty sure we can go turn coordinator ball inversed, like that. And we'll see if this works. I don't know if it worked last time, but couldn't hurt. Click run, and it works perfectly. So if you need to, there's actually an event, turn coordinator ball inverted, but we'll show you turn coordinator ball and then invert it ourselves just by flipping the signs right here, -28 and 28. Or like if this value was 35 and this value was -20, you would just put like -20 up here and 35 there. So like you would swap the values, not necessarily swap the sign. Now click run, and for the final time we will test our turn coordinator. Los Angeles. Also, I don't know why. Oh, hey, they fixed it. The buildings are not flying. Oh, but there is a glide slope in the air, so you know you can't win them all. For the final time, let's test our turn coordinator right here. Parking brake off. We are ready to go. Now you'll see it coordinates over here. It even stops where it's supposed to. Voice crack! And we're all good to go. Oh dear. This is how most of my flights end. Hey, we saved it. You'll see right here, if we fly straight and level, which is not an attitude wow, look at that. Not an attitude I'm necessarily good at flying. If we fly straight and level and coordinated, then we should be in the center on both of them. And it's looking like I'm doing pretty alright. Step on the ball. How do you step on the ball with a joystick? I have no clue. But yeah, you'll see it's in the middle when it's supposed to be, and not in the middle when it's not supposed to be. I'm going to try to land on this semi, and then I'm going to end the video, I think. Or no, on this overpass. That sounds fun. my flight instructor would be so sad watching me do this video. He'd be like, "Where's your airspeed? Where's your flaps? What's your pitch? Pitch for airspeed, power for altitude." Okay. All right. I would like to, before I hit the building, or after, that works too, I'd like to just say a huge thank you to all of the supporters of the channel, all of the patrons. Thank you so much for supporting me, helping me to make these videos. Especially thank you to Altimeter Motives, who helps provide some of the studio equipment. Go check out their shop. And also, thank you to all of these wonderful people on the page. Happy landings, and have a good one. I'm so out of it. I have a mustache though. Did you notice?